Hello students, today we are going to discuss JEE Mains 2026 January 21st evening shift. That question only we are going to discuss today. Alright, come on, let us discuss. When 8.74 gram of manganese dioxide is treated with HCl, hydrochloric acid, then what will be the weight of chloride Cl2 gram obtained? Cl2, it is a product. Reactant, it is MnO2 plus HCl. Molar mass of manganese dioxide they have given. Now, what is the product, that is chloride product? What is that gram? How much it has gained, obtained? That is what the question. Okay, now let us write that equation so that you will come to know the clarity. Now here, MnO2, manganese dioxide, react with HCl. You will be getting what it is, MnCl2 plus Cl2 plus H2O. Right. Now here, when we are balancing this equation, now here O2, oxygen 2 is there. So here what it is, 2. And here 4 hydrogen is there. So naturally here 4. Chlorine here 4 it is there. Here, yes, it is 4. Yes, balanced that equation. Now, molar mass of MnO2. So molecular mass of what it is, MnO2. MnO2. How much it is? 87.4 gram per mole. Gram per mole. Okay, now here when 8.74 gram of MnO2. So given mass by molecular mass, right? Number of moles. First and foremost, let us find out the number of moles. Number of moles of MnO2. So MnO2, what it is? Given mass. What it is? Given mass 8.74. No. So 8.74 divided by, that is gram, and molecular mass of MnO2 just now we have found, no, that is 87.4 gram per mole. So gram and the gram will be cancelled. Okay, now this is 0.1 mole. Easy. Right, now how do we identify that weight of chlorine? Okay, now weight of chlorine Cl2 obtained is how much it is actually? Number of moles into molar mass of chlorine. Okay, so number of moles into molar mass of chloride Cl2. Right. Okay, now here number of moles of this one, because this is the reactant and you are getting the product is Cl2. So number of moles from here only now. So 0.1 into what it is? Molar mass of chloride, it is 35.5 plus 35.5. So what it is? 71, no? 71 gram per mole. So this mole, this also mole, right? This mole and that mole will be cancelled. So what is that answer? You will be getting 7.1 gram. So how much it has obtained as a product of chlorine? This is a product, right? This is a product of chlorine. How much it has obtained from that? What it is? 8.7 here. The given mass how much is 8.7 gram of manganese dioxide. So here 7.1. So 7.1 only is the correct option. I hope you got the clarity. This is very simple. First and foremost, number of moles you have to identify, then number of moles of the reactant, main thing, divided by, number of moles into molar mass of the product what we have to obtain, right? Okay. I hope you got the clarity. Come on, let us go to the next question. The next question, calculate bond energy of carbon-hydrogen bond NCH4. The given data, that is delta H formation of CH4 gaseous is equal to minus X kJ per mole, and delta H sublimation of carbon, it is Y kJ per mole, and bond energy of hydrogen, that is Z kJ per mole. Okay, now here when we are looking at this question, we can bring that equation so that you will come to know that more clear idea about what formula can we use among this. Right now here carbon, it has to be a solid form. Carbon, it has to be a solid form, and the hydrogen, it has to be a gaseous form, and it gives CH4, it is a gaseous form. Okay, now here 2, so automatically here you're getting 4, of course that. And here what formula? So which is based on this? This is, can we relate that Hess's law? So we can go for the enthalpy cycle of Hess's law. Enthalpy cycle of Hess's law. Right now here, what formula can we use according to this? Delta HF formation equal to delta H sublimation plus 2 into delta H atomization. Okay, so atomization H2, right? Atomization from here only its bond breaks, right? So atomization minus delta H atomization of CH4. Okay, can we apply this values now here? So here delta H formation, that is XYZ they have given, no? So delta H formation, it is minus X equal to here delta H of carbon. So delta H of carbon, that is sublimation of carbon plus 2 into bond energy of hydrogen, that is HH, right? And minus 4 into here CH4, now 4 into bond energy of CH, carbon and hydrogen. Okay, now can we bring that point over here? So minus X, here minus X equal to 2, that is here sublimation, that is Y plus 2 into Z, that is Z minus 4. Okay, so this is the way we can bring. Okay, now we want what it is? CH4 only, right? Okay, that means bonding energy of carbon hydrogen equal to Y plus 2Z plus X divided by 4. Can we bring in this way? This is completely based on Hess's law cycle that you have learned to know at that point. Okay, so that is only. So according to this point, can we bring this? Yes, Y plus 2Z, that is atomization, 2 into Z plus X divided by 4. So this is the formula we can bring to solve this sum. Okay, now which is the correct option? Y plus 2Z plus X divided by 4. Yes, of course, 100% this is option 2. See, this is a simple question. Hess's law you have learned, so that through that idea you can solve this. While writing this equation only, you will come to know that idea. This is carbon and 2 H2, that no hydrogen, and you are getting that formation of what it is, CH4. Okay, hope you got the clarity. Come on, let us go to the next question. Following transition are made by an electron in an hydrogen-like species. Find energy order of emitted photon. So you know very well hydrogen spectrum, that is Lyman, Balmer, Parston, bracket, Fund. So that actually, which is lower values, it gives higher energy. So the energy gaps, I just bring that idea for you to understand. Here, when you see this picture, this is that hydrogen spectral series. You might have learned this. So N1, it is Lyman series. Okay, so N1, 2, that is level actually very smaller, but the energy gaps, it is very larger. You see this energy gaps, it is from here to here, that is energy gaps as larger. That is what I just mentioned. Smaller values, higher energies. And the same way, see, N1 equal to 1, N2 equal to 2, 3, 4. So from lines are coming from 2, 3, 4, 5. So energy gaps will be more higher. So lower values, higher energies. And the same way, N2 equal to 2, N1 equal to 2, N2 equal to 3, 4, 5. Like, so that is what just I bring that idea for you to understand for these spectral lines, what you have learned in the grade 11. And the formula what we are using, energy delta E equal to 13.6 Z square into 1 by N1 square minus 1 by N2 square. So Lyman, it is a very higher energy. They are talking about energy now, highest energy, and values will be lower. So N1 equal to 1, N2 equal to 2. The same way, Palmer, N1 equal to 2, N2 equal to 3, 4, like. Okay, so which is the lowest, that will be the highest energies. They are talking about energy. Find the energy in order of the emitted photon. So this is the highest energy. Then second one, third one, fourth one. So Lyman, Palmer, Parston, bracket, Fund. So that means A, what it is here, A, B. So this A, it is higher than B, it's higher than C, and then D is the last one. So lowest energy, it is bracket, Fund series. Okay, hope you got that idea. So according to this option, option 2 is the correct option. Simple logic one. Okay, come on. Let us go to the next question. The next question, for Daniel cell, select correct variation of E naught cell with time. See, generally for this question, E cell versus time, E naught cell with versus time, the two of things we can identify. So E cell with time, right? E cell versus time. So usually the slope will go for that downward E cell. I'm talking about E cell. So the time here E cell. So the slope will go down. Whereas E naught cell versus time. Okay, this is E naught cell versus time. The slope will go what it is horizontal way. That means it is constant. So this is time and the E naught cell. Okay, so this is horizontal way in that straight line. So this is E naught cell versus time. That Daniel cell, if you go through clearly, this is the way many times we have gone through this question and it has repeated question. Last previous question also we have seen the same such kind of question, right? Even in board also it has repeated. Okay, so this is very important and simple way. So which is the correct option? E naught cell versus time. So the straight horizontal line only as the correct option. I hope you got the clarity. Come on, let us go to the next question. The next question, A gaseous state gives B gaseous state plus C gaseous state. Initial pressure of A is 1 bar, that means pressure. After 100 minutes, total pressure becomes 1.5 bar. Find the value of rate constant of the reaction assuming first order reaction. Okay, so here morning shift, no, so morning shift we could not find such kind of questions. Evening shift we are getting more questions from what it is, physical chemistry. Yes, come on. So here let us check with that. A gaseous state, it gives B gaseous state plus C gaseous state. Even physical chemistry, if they are giving also logical way thinking only, they are giving, they did not give much like what to say, calculation part. They are not giving logical way thinking. How do we get the concept oriented only they are asking. Right now here 1 bar, the first one it is 1 bar, and then when that reaction started here 0 0 only, but after reaction here 1, that is also pressure has gone, so here also 1p and here also 1p. So that means here pressure, it has pressure becomes 1.5 bar. So that means here total pressure, let us check. So total pressure is equal to P total. Okay, total pressure, total. So total pressure equal to 1 plus P. Okay, so 1 plus P equal to here what it is. This is actually total pressure 1.5. So 1.5 bar, right? So 1.5 bar equal to 1 plus pressure. So P equal to here what it is 1.5 minus 1. So you are getting 0.5 bar, right? Right now, we are going to use that first order reaction. So first order, what is the formula generally we use? So K equal to 2.303 divided by T log 10, log 10 base 10. Here, what it is? P naught by PA, right? Okay, so this is the formula we'll be using, right? So P naught initial and final. Right now, here what it is? First one, it is K equal to 2.303. Simple ones, 2.303. Time, how much? They have given 100 minutes, right? 100 minutes log 10, log base 10. So this is 1 by zero point 0.5, what we have received. Okay, so 1 by 0.5 means this is log base 10. Log base 10, it is 2, right? So when you calculate, so this is 2 means, so K equal to K equal to 2.303 divided by 100 minutes. Okay, log 10, how much it is actually? 0 point, that is what it is, 0.3010. Log 2, it is 3010. So when you calculate this, you will be getting how much? It is 0.00693 minutes. Okay, minutes inverse. Right now, how can you bring it here? 6.9, 6.9 and 10 to the power of, yeah, what is that they have given? 10 to the power of minus 3, right? Yeah, 10 to the power of minus 3, because here two zeros are there, no? So that point when it comes over here, so 10 to the power of minus 3 minute inverse, because this minute goes upwards, right? So which is the correct option? The option it is, the option it is 2, right? I hope you got the clarity. So option 2 is the correct option. Okay, come on, let us go to the next question. Simple. What it is, they are asking about first order reaction. So first order reaction, according to that you can apply the value, you will get the answer. Come on, let's go to the next question. Next question, statement 1, the correct order for radius is aluminum, it's greater than Mg, it's greater than Mg2 plus, it's greater than Al3 plus. And statement 2, atomic size always depends on electronegativity. This is totally wrong. Atomic size, how is it possible? It depends on electronegativity. See, atomic size, that is based on what it is, size, number of shells, it depends. Right now here, for example, here this picture shows very clearly, right? I'll explain to you. So this is now, for example, hydrogen atomic number 1, and lithium atomic number 3, and sodium atomic number, what it is, 11, potassium atomic number 19. Okay, so hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So when we go for electronic configuration, this is 1s1, and what it is, lithium 1s2, 2s1, and sodium, what it is, 1s2, 2s2, 2p6, 3s1, and potassium, it is 4s1. So in that way, outermost orbital, the electrons, that shell, number of shells are increasing here. This is, you see here, shell number 1, and here second shell, and this is third shell, and this is fourth shell, and this is what it is, rubidium, cesium, francium, fifth shell, sixth shell. See, generally from top to bottom in the periodic table, from top to bottom, what it is, elements atomic size is increasing, that you know very well, that is the rule, right? So from top to bottom, atomic size is increasing, but it does not depends on electronegativity or electropositivity. No, not at all. That is not the correct option at all. I hope you got that idea. So the second one, it is wrong. And the first one, the correct order for radius, you know what do you mean by radius? The atom, it is there, and this is that radius. Okay, middle point to that outermost shell, so that is that atomic radius. So that is for aluminum, it is greater than magnesium, it's greater than Mg2 plus, is greater than Al3 plus. See, actually magnesium comes first, next to only aluminum. So magnesium, from left to right, atomic size, it is decreasing. See, top to bottom it is increasing, left to right it is decreasing. So that means here magnesium next to aluminum. So magnesium atomic size is bigger than aluminum. So but here aluminum, it's greater than magnesium, they mentioned. So totally it is wrong. So magnesium, it's greater than aluminum. Then next to Mg2 plus, what it is, Mg2 plus, then Al3 plus. Okay, fine, this is true. But Al, it's greater than Mg, it's totally wrong, because magnesium is here, aluminum it's there. Magnesium atomic size is bigger than aluminum. Why? Because from left to right, atomic size, it is decreasing in the periodic table. Hope you got the clarity. Even this picture also shows that very clearly, and this picture also, you are getting that idea. Hope, fine. Come on, let us go to the next question. The next question, statement 1, bond dissociation energy order is Cl2, Br2, F2, and I2. Statement 2, bond dissociation energy is independent of bond order. See, the second statement, actually, it is totally wrong. Why, you know? Because bond dissociation energy increases, bond order also will be increasing. So actually what it is, bond dissociation energy is directly proportional to bond order. But here it is independent, it has mentioned. So this is totally wrong. And the first one, bond dissociation energy of halogen Cl2, Br2, F2, I2, it is actually correct. Bond length, it is indirectly proportional to bond strength. So two main things we can identify here. So here number of anti-bonding increasing, and smaller size, actually better overlapping for fluorine. Why? Because it is a smaller in size. Chlorine, bromine, fluorine, iodine. So here chlorine, fluorine, chlorine, bromine, iodine, only no halogens. But here chlorine, bromine, fluorine, iodine, mainly it is that size, that smaller in size. And next to one, electron repulsion takes place. These are the two main points. And here also it is bond length and bond strength. I think you got that idea about that. So these are the points will help us to identify the answer. Actually, the first one, it is correct only. The second statement, it is totally wrong. Hope you got the clarity. So the statement 1, it is correct, and statement 2, it is false. So option 3 is the correct option. Okay, come on, let us go to the next question. The next question, sodium chloride reacts with H2SO4 along with K2Cr2O7. So what is the product? The product of chromyl chloride oxidation state we have to identify. Okay, now here let me write the term. Equation, balancing equation, NaCl plus H2SO4 plus K2Cr2O7. It gives here what it is. Here CrO2Cl2, chromyl chloride plus potassium hydrogen sulfate, KHSO4 plus sodium hydrogen sulfate, NaHSO4 plus H2O. So this is the product. Okay, balancing that equation. Now here K2 potassium, so here 2 and oxygen 7 it is there. Okay, now water molecule and here chromium also 2 it is there. So if we put it 2, chlorine 4 it is there. So here we will put it 4 and sodium also 4 it will be there. Now hydrogen, so that means 4 plus here oxygen. Okay, now here if we put it 2 means here 4 plus 4, 8, 9, 10, 11, 12. Okay, so that means 6, 6 2s are 12. Now oxygen how much it is? 4. Here what it is? 4 for 8. Okay, is it balanced? Is it balanced? Okay, 4 NaCl and here 6 H2SO4 and yes, so 2 CrO2 Cl2 plus here 2 KHSO4 and next one here 4 NaHSO4. Yes, it's balanced. Yes, okay. Now in that point CrO2 Cl2. So what is the oxidation state? This is the product. That is what they are asking, right? What is product chromyl chloride? What is the oxidation state? Okay, now here actually chromyl chloride, here directly we can go for it. This is X plus here 2 into minus 2, right? Oxidation state of this is minus 2 plus here 2 into minus 1, okay, equal to 0. Minus 1, this is not plus. Minus 1 equal to 0. Okay, that means here what it is? Minus 4 plus here what it is? Minus 2. So you will be getting what it is? Plus 6. So X equal to plus 6 oxidation state. So X equal to plus 6 oxidation state, here what it is? Plus 6 oxidation. CrO2 Cl2 only, not Cr2 O2 Cl2. No. So that means the product it is 1. Okay. So product CrO2 Cl2, it is product, it is 1. Yeah. Option 1 is the correct option. Okay. Come on, let's go to the next question. The next question, the correct order of electron affinity is Cl is greater than Br, it's greater than S is greater than O. And statement 2, correct order of ionic character is PbCl2, it is lesser than PbCl4, it's lesser than UF6, it's lesser than UF4, and it's lesser than SnCl4, it's greater than SnCl2. Okay, now here the statement 1, what it has mentioned, electron affinity. So electron affinity, when we are talking about in the periodic table, electron affinity. Okay. So electron affinity, electron strength, the strength of that electron in the periodic table, it mentions very clearly moving down the group, okay, from top to bottom, moving down the group, electron affinity, it is decreasing from top to bottom. So electron affinity, which is decreasing, whereas left to right in the periodic table, electron affinity, it is increasing. So in that way speaking, here chlorine, bromine, sulfur and oxygen, it is exactly true. The first statement, it is correct. When we are talking about second statement, they are mentioning about ionic character. So ionic character means here for the compounds lower oxidation state, higher oxidation state, we have to check. So lower oxidation state, here PbCl2, that is Pb2 plus and Sn2 plus. Pb2 plus and Sn2 plus, it's more ionic than what it is, Pb4 plus, actually it is, yeah, Pb4 plus and Sn4 plus and U6 plus, they mentioned, right, 6 and 4. Yeah, so that means this is ionic character only we are talking about. So Pb2 plus and Sn2 plus is more ionic than Pb4 plus and SN4 plus. So that means lower oxidation state, it will be more ionic than higher oxidation state. So in that way speaking, lower oxidation state, it's more ionic than higher oxidation state. So which is correct among this means here the first one it is correct, but the second one it is incorrect. This is a second statement, it is not the correct way. So according to this, okay, so statement one is correct and two it's not correct. Okay, so this is the correct option. Okay, come on, let us go to the next question. The next question, among MnH2O 6 times 2 plus and CrH2O 6 times 2 plus, the more stable complex is MnH2O 6 times 2 plus. And the second statement, magnetic moment of K3FeCN6 is greater than K4FeCN6. Okay, so according to this, statement 1 actually it is correct. Why? You know, here in this point, Mn, when we are talking about Mn and Cr, so Mn it is half filled, right? Half filled electronic configuration. So half filled and completely filled are more stable than what it is, minimum filling. So this is D5, right? Whereas here D4 only. So D5 it is more stable than D4. D4 it is ready to lose the electron. So naturally half filled and completely filled are more stable complex. Yes, of course, 100% this is correct. And the second one, magnetic property K4FeCN6 it's greater than K3FeCN6 it's greater than K4FeCN6, 100%, because while going for what it is, unpaired electrons, electronic configuration of unpaired electrons, K3FeCN6 actually is having what it is, one unpaired electron is available. So one unpaired electron. So one unpaired electron means what it is, Bohr magneton formula here, root of n into n plus 2. So that means 1 into 1 plus 2. So root of what it is here, root 3 you'll be getting, right? So Bohr magneton it is root 3. Okay, hope you got the clear idea about this question. So which is the correct option? This is very simple. So option 1 is the correct option. Okay, come on, let us go to the next question. The next question, rate of reaction of nucleophilic substitution reaction with KCN in polar protic solvent. So nucleophilic substitution reaction 100% it is there in polar protic solvent KCN. It is strongly favors for SN1 reaction, right? So SN1 reaction determined by stability of carbocation. So stability of carbocation, right? Okay, now here as we observe this carbocation intermediate formed after the leaving group of bromine, right? So after the leaving group of bromine, actually it releases right now OH, this is OH and this is NH2 and NO2 and this also NO2. So meta position and para position. So in that way, according to this, here plus I electron donating group. Okay, electron donating group. The same way this also electron donating group. So electron donating group as we are observing, B is the first one. Okay, so B will be the highest according to this. And the same way next highest it is what it is, OH. So that means A, right? Okay, A. So NH2 it's greater than OH, right? Next one, it is meta and para. So meta and para, as we observe, both are electron withdrawing group. So both are electron withdrawing group. This is meta position and this is para position. So in that meta position, what it is there? Here minus M effect, whereas here minus I effect. So minus M and minus I, actually minus M it's greater than minus I. So naturally here D it's greater than C. That's all the point we got it. BACD. BACD where it is. Okay, option D is that option 4 is the correct option. So here what you can bring, meta position of NO2 it's greater than para position of NO2. Hope you got that idea. Okay, so option 4 is the correct option. So many questions, so long, 10 questions more than that we have gone through. All the 10 questions are based on physical chemistry and inorganic chemistry. Now only organic chemistry appeared. Seriously, this question, it is like little more higher level comparatively what it is. Morning shift, what we have gone through last 3 videos, it's totally different from this evening shift. Evening shift, little higher to that moderate level, I feel. Okay, come on, let us go to the next question. The next question, match the correctly from the reagents given in column 1 and column 2 with the named reaction given column 2. Right now, this is completely based on named reaction. PD, BASO4, that is Rosenman reduction. Okay, so this is a reduction process. So the reduction process, acyl chloride, that means acid chloride converted to aldehyde. So this is Rosenman reduction. So this is fourth one. And CrO2Cl2 plus carbon disulfide. So this is etard reaction. So etard reaction, this is toluene converted to benzaldehyde. Toluene, it is actually hydrocarbon. Hydrocarbon converted to benzaldehyde. So etard reaction, it is 1 and this is 4. And SnCl2, it is a Stephens reduction. So Stephens reduction is actually what it is. Here also cyano compound converted to aldehyde. Cyano compound, cyanide group converted to aldehyde. So here this is actually SnCl2, that is Stephens, 100% Stephens reduction. And the next one, COH, what it is, carbon monoxide with HCl and aluminum trichloride. So this is actually Gattermann-Koch reaction. So Gattermann-Koch reaction also, this is benzene converted to what it is, aldehyde. So all comes from aldehyde only they have mentioned. So this is third one, Gattermann-Koch. See, all these questions taken from what it is, named reaction, and the next one what it is, reagent, and you have to find out. So this simple it is. First two are hydrocarbon. Even for board also it will be easy for you to remember. So first two, this is a what it is, acyl chloride converted to aldehyde. This is second one, it is toluene converted to aldehyde. Then third one, it is cyano compound converted to aldehyde, and the last one, benzene converted to aldehyde. So 4 1 2 3, 4 1 2 3. So option 3 is the correct option. See, very easy. Organic questions are very easy comparatively. Physical and inorganic. Physical, inorganic depth level they are asking, not moderate level, depth level they are asking. Even physical chemistry also. But morning shift, they did not touch that physical chemistry. Slight touch only they asked. Organic, most they have asked. Yeah, okay. Some of the questions, that is according to that. Okay, now the next question. The next question, it is very simple and interesting also. Cis 2 butene and trans 2 butene. Cis and trans, they themselves have given. So definitely this is belongs to what it is, geometrical isomerism, stereoisomerism. Okay, so this is actually it is here. This is 2 only. So this is 100% 2 only. Diethyl ether butanol OL. So this is OH and this is ROR. Okay, so ether. So this is actually functional group. So this is what it is, 1. And the next one, it is 1 butene, 2 butene. So positional isomers. So this is 3. It's a straight word. Okay, N-pentane and neopentane. N-pentane, even the same question they asked in morning batch also. N-pentane and neopentane. See, N-pentane, it is 5 carbons in a long chain structure. 1, 2, 3, parental chain. Okay, 1, 2, 3, 4, 5. The neopentane, it is 1, 2, 3, 4. And this is 5. Carbon, 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 carbon. This is neopentane. So this is 4. Straight they have given 3 and 4. Okay, so option, what it is, what is the option? 2 1 3 4. 2 1 3 4. 2 1 3 4. Option 2 is the correct option. I hope you got the clarity. This is very simple. Okay, come on, let us go to the next question in our next video. Yeah, thank you for watching. I hope you got some ideas about these questions, so this will help you, I hope. Thank you so much, and thanks for watching. Thanks for your valuable time you spent and watching this video. Thank you so much.